In this video, we're going to be finding the domain of a fractional function involving radicals. Okay, so a couple things we need to know before we go into this. First of all, you cannot divide by 0 in a fraction. You can't have 0 in the denominator, right? And in involving the radicals, you cannot have negative numbers inside of a square root because the square root of negative numbers give you non-real answers. Okay, so we're only interested in the numerator if there is a square root. Remember, the numerator is the top. Okay, so if there's a square root on the top in the numerator, then we can set whatever is under there, whatever's under the square root, greater than or equal to 0. You can set it greater than or equal to 0. That makes sure that anything that's inside the square root will stay 0 or bigger. Okay, now if it's in the denominator, if there is no square root, all you have to do is set the denominator equal to 0, solve for the excluded values, and then exclude them. There are other videos that I've made on this, and if you need a refresher, you can go back and watch those. Okay, if there is a square root, then you set whatever's under the square root greater than 0. Now notice the difference between this and this. Okay, this had greater or equal to 0 when it's in the numerator, right? So you can actually be equal to 0, and that's fine in the numerator. That's the top. But on bottom, you can't have a 0 in the denominator. So we have to make sure that it's greater than 0, not just greater than or equal to 0. Okay, so we're going to find the domain of the function. We're going to write our answer in interval notation. Okay, so on this one, there's no square root on the top, so we can ignore that. On the bottom one, there's a square root on bottom, so we need to set whatever's inside here greater than 0. Okay, so that will be x minus 4 is greater than 0. If we solve that for x, you'll get x is greater than 4. Okay, that seems to be the only restriction on this. Okay, so we can say in interval notation, what is our smallest number if x is always going to be greater than 4? Well, our smallest number will have to be 4 because everything else will be greater than that, right? So no line underneath, so this will be a parentheses, and then it keeps getting greater and greater and greater, so it heads out towards infinity. Okay, so that is the domain. Okay, let's take a look at this one. Now, there's a square root over the whole thing, so what I'm going to do is, first of all, rewrite this as a square root of the top and the square root of the bottom. You can do that, okay? Now, I look at the square root on top, and I see there's no variable there. There's no x, right? So I can just ignore that. Now, if that had like a 6x, then I would have to do something with it. But since it's just the square root of a number, we can leave it alone. So we go to the bottom. We see that there's a square root. We see that we need to set whatever's inside the square root greater than 0. So you'll get x minus 2 is greater than 0. Add the 2 to both sides, and we get x is greater than 2. Okay, so that's our domain. There's no other restrictions, but we need to write it in interval notation. So if x is greater than 2, not greater or equal to, right, because it was on bottom, so greater than 2 means our smallest number is 2, and it goes out towards infinity. So that's our domain, from 2 to infinity. Okay, let's look at this third one. Now we do have a square root on the top here. Okay, so with a square root on the top, you need to set what's inside greater or equal to 0. So x plus 6 greater or equal to 0, because it's okay for the numerator to have a 0 in it. It's just not okay for the denominator to have a 0 in it. Okay, so we subtract the 6 from both sides, and we get x is greater than or equal to negative 6. That takes care of the top, but now we have to look at the bottom, and we see that we have x plus 1 down there. There's no square root. So I will just set x plus 1 equal to 0 and solve, and that will be an excluded value. So I'll subtract 1 from both sides to get x is equal to negative 1, which actually means x is not equal to. It's an excluded value. Okay, so this one's we're going to have to split it up and write it in two different parts of this domain. Okay, first of all, we know that x is always going to be greater than or equal to negative 6. Okay, so what's our smallest number that x could be? Well, negative 6. So I'll use a bracket because it had a line. Okay, so negative 6. Now, as I'm going along, could I go all the way out to infinity and be done? Well, no, I have this excluded value here, right? So it says x cannot equal to -1. Okay, so I have to put that in there, say I exclude it, and I exclude it by writing it down and putting a parentheses, saying that, yes, it goes right up to -1, but it's not included, right? And then I use a union, and I start again at the -1, the number that got excluded. Again, there's prior videos on this if you want to go watch them. And then we keep going until we get to where? Well, how far out? Are there any other restrictions? No other restrictions, so we keep getting bigger and bigger. So our domain is -6 to 1, union -1 to 8, and the only one that's included is the -6. Okay, 3 more problems. On this one, looking for the domain, we notice there's a square root at the top. Okay, so we set the square root 3 plus x greater than or equal to 0 and solve. So that would be a subtraction of 3. So x is greater than or equal to -3. And then we move on to the bottom, the denominator. There's no square root, so we can just set this equal to 0 and solve. So I'll subtract 1 from both sides. I get x is equal to -1. So x cannot be -1, and x has to be greater or equal to -3. So what's our smallest number in our domain? Well, x has to be greater or equal to -3. So -3, it's a bracket because there's a line underneath. Okay. And then I cruise along. Do I go all the way to infinity? Well, I have to stop and look at this. That's an excluded value. So I go from -3 to -1, but I have to exclude 1, just like I did in the last problem. So I put a parentheses, a union, another 1 with a parentheses. So this is excluding the 1. And then I keep going out to infinity. So that's the domain of that one. Okay, let's look at this one. So again, we have a square root on top. So we say x plus 3 is greater than or equal to 0. Subtract 3, we get x is greater than or equal to -3. Okay, and then we've got this. There's no square root, so we just set -3x minus 7 equal to 0. Let's add the 7. That gives you -3x is equal to 7. Divide the -3, and you get x is equal to -7/3. That's our excluded value, so we'll throw it out. Okay, so we start at -3. It says x has to be greater than or equal to -3, so that's our smallest one with a bracket because of the line underneath. Then we have an excluded value at -7/3. Okay, exclude meaning parentheses, put a union, put another 7/3, and then it keeps getting bigger. It goes on out to positive infinity. Okay, one more. We have square root in the top, so we say x plus 7 is greater than or equal to, because it's on the top, not the bottom, 0. So we subtract 7 from both sides. You get x is greater than or equal to -7. Okay, then on this, there's no square root, so we set -2x minus 8 equal to 0. Add 8, and we get -2x equals 8. Divide -2. So we get x cannot be equal to -4. That's our excluded value. Okay, so we start x has to be greater than or equal to -7. So that's where we'll start with a bracket. And then we go to -4. That's our excluded value. So let's put parentheses. And then we go to infinity. And that's it.